Okay, so here is the lens worksheet that you need to do. Again, you're going to be using those steps that we talked about in the notes. This first one is kind of a bit different than the ones that we're going to be looking at. So all the lines here, it says it's a distant object, so all the lines are parallel to P, and we know if the incident ray is parallel to P, it's going to go through the lens at F. So all of the lines will converge at F, and essentially no image will be seen, but you will not be seeing that on an assessment. But that is how all the rays interact with that lens. So looking at B, we have the image here, and then we are going to be starting at the top of the object like we always do. And then we're going to go parallel to P because that's the first incident ray in the lens. So parallel to P, again, P is that line that is connecting all of those dots. So parallel to that P, which is that line here. And once you get to the middle of the lens, you're going to stop. So incident ray is parallel to P, and then that's going to go through the lens at F. So our incident ray, and then it's going to go through the lens at F. And again, we have our dotted line for our incident ray and a solid for our reflected ray. The next step is starting at the top of the arrow, and we're going to go through O. And once we get to O, we're going to keep going straight. So again, top of the arrow, going through O, keep going straight. And our lines intersected here, so that will be the top of the object. And that is what this object would look like in a lens if it was located here. So this is what the image would look like, and we can answer those questions like we did for the mirrors. It is located between F and 2F. It is real or is it virtual? So again, if it's located on this side of the lens, it's virtual. If it's located anywhere on this side, it is considered real. So that would be a real image. Looking at the arrow here, it is pointed up, and looking at the arrow now, it is pointed down. So it's going to appear upside down, and we call that inverted. And then looking at the original size to the size that would appear in the lens, it got smaller, so it would be reduced. Looking at C, we are going to have the image here at 2F. Again, our incident ray, our first step would be parallel to P, and then when we got to the center of the lens, we stop, and it's going to go through the lens and go through F. So parallel to P, stop in the middle of the lens, draw a line through F. The next thing you're going to do is start at the top of the arrow, and you're going to go through O, and then you're going to continue to go straight. My lines are not perfect. If an arrow is located at 2F, it's actually going to end up at 2F as well over here. So my lines are not perfectly parallel or straight, otherwise they would have connected here. And so the image is located at 2F. It is considered real because it's located on this side of the lens. It is inverted because it was pointed up, but now the arrow is pointed down, so it's going to look upside down. And it is going to be the same size. So it's located at 2F, it's going to be located at 2F over here, and it's going to be the same size. looking at D, we have the arrow here. We're going to be going parallel to P. When we get to the middle of the lens, we're going to stop, and it's going to go through F. Our second incident ray, we're going to go through O, and then continue going straight. These lines will eventually converge somewhere over here, and that would be what the image would look like in that lens. The image is located behind 2F. It is considered real because, again, it's located on this side of the lens. It is inverted because it was pointed up, but now it is pointed down. And it would be considered enlarged because it started out this size, and the image would now look larger. For E, we're going to go parallel to P for this object. So again, using the same steps we have been using. Once we get to the center of the lens, we're going to go through F. Our second incident ray, we're going to start at the top of the arrow, and then keep going straight. If my lines were perfect, these lines would be parallel. So just like we saw this happen in the mirrors, it's located at the focal point. And that means that there is no image that will be located because these lines will never converge, regardless of if you continue them this way or if you continue them this way. So no image will be seen, and so there's no reason to answer those questions. And again, that is always true if it's located at F. So anytime an image is located at F, the focal point, no image will be seen through that lens. And then finally, this is one that is going to be different. It's located in front of the focal point. So the image is located in front of this focal point here. That would be going parallel to P, and then it will go through F. And then our second would be through O and keep going straight. Notice that these are not parallel, meaning they would eventually intersect if you were to elongate this line here. So for this one's a bit different, like we've been looking at. It is actually located on this side of the lens, so it's you can say same side. It would be considered a virtual image, meaning it's located on this side of the lens, left side of the lens. It is erect or it's upright, meaning the arrow was pointed up and it would be appearing to be pointing up as well. And it would be considered enlarged because the arrow started at this size and got larger in the image. And that is it for the lens.